my name is Linda Boyd. I am a junior at St. Joseph's University studying chemical biology.
Hi, I'm Brittany Byrne and I'm a junior at St. Joe's and I'm studying chemical biology. We're filming this project for our behavioral neuroscience class with Dr. Becker in the spring of 2017.
This video is a good tool in that it allows us to document everything from the research to the surgeries and all the struggles that we go through during the whole entire process.
We're definitely nervous and overwhelmed now, but we're excited to be able to share our experience and to see our progress throughout the whole semester.
Here we learned how to perform an interrupted stitch on a pig's foot while carrying out sterile technique.
We're about to cut into our pig's foot for the first time. So we just prepped it and now we're taking a little break and then we're going to gown, then scrub, then glove. Yeah.
And then we get to cut into it.
Remaining sterile wasn't as easy as it seemed. You don't realize how many things you normally touch when you aren't allowed to touch anything at all.
We were definitely excited to see the surgery for the first time and to visualize what we were going to be doing. We're definitely a little nervous, but hopefully our surgery goes as smoothly as the one we watched.
One thing that we have learned is that animal testing is so complex and there's so many factors involved that we didn't even realize.
This was the posterior that we started from, so this is one lateral, and this is the other.
This research project puts into perspective all the work that animal researchers do.
Our study is comparing how various concentrations of alcohol will inhibit fear compared to a lesion to the amygdala.
So in previous research we found that a full amygdala lesion will inhibit a fear response, and we also found studies where ethanol will decrease the fear response as well, but none of them have compared them to each other. So we thought that would be interesting to do in our project.
Behavioral testing will be carried out through the use of a light dark box. The dark box is where the rats will prefer to be since they prefer darkness. When the animal enters the light side of the box, that will be perceived as a decrease in fear. A Fruit Loop will be used as incentive to enter the light box. A robot will be used to intimidate and scare the animal. This is how we will be able to observe the change in the fear response after ethanol injections and an amygdala lesion. The animal did not know to go into the light box to retrieve the Fruit Loop. So to fix this problem, we had 3 one-hour training sessions for each rat where we placed the Fruit Loop further and further from the entrance of the light box. After persistent training, it did seem that the animals understood the task that they were given and we were able to begin our behavioral testing.
When we first tried to inject the anesthesia into a rat, kept kicking when we would insert the needle, so a couple times the needle was actually kicked out of our hands, so it took us a couple tries to get the full dose of the anesthesia into the rat.
It was really just figuring out how to hold the rat and how I should inject, and we were really concerned about that because our whole project, a majority of our project focused on injections, so we were really happy to finally get that down during the surgery. So here we have successfully administered the anesthesia. It's actually quite amazing how fast the animal goes under and how deeply sedated it is. It is well understood how anesthesia works, but observing it firsthand is a completely new experience. Another interesting part of the surgery is that the eyes do remain open even though the animal is under anesthesia. Applying mineral oil drops prevents the eyes from drying out during the surgery. When beginning the surgery, we tried to be as gentle as possible when working with the animal. However, we realized that the skin was very thick and that we would have to apply a large amount of force in order to even break the skin and make an incision. Once the incision was made, we started to scrape away the dura and look for bregma. Even though we did observe these steps during the practice surgery, doing it on our own for the first time was a whole new learning experience.
We were nervous because it had been so long since we had sutured, and I mean, we picked it right back up, but that was probably what we were most nervous for.
And especially because our rat was waking up during
Yes.
that time, so we had to do it really quickly.
So we just finished, and we're just waiting for our rat to wake up now. It took
4 hours?
4 hours. We had a lot of issues. Our rat kept waking up, and it wouldn't stay on the ear bars, so that was an issue.
Yeah, but other than that, everything went well. Yeah, it's just a fast metabolizer, I guess. And it peed a lot, so.
Linda and Brittany did a great job at their surgery.
Based off of previous literature, we expected the rat to back up into the dark box upon the approach of an intimidating object, in this case a robot. This means that the animal is exhibiting fear. After the surgery, if we correctly lesion the amygdala, we should expect to see no fear behavior exhibited in the rat. This means that the rat should not immediately retreat back into the dark side of the box when approached by the robot. We observed that after the lesion, there was definitely a decrease in fear. In some cases, the rat would even reach underneath of the robot to retrieve the Fruit Loop.
Injections. We did 3 different doses of the ethanol. We used Everclear and then just diluted it down. We did it once a day in 3 consecutive days, and each day it would get a different dose, and then we would just observe its behavior, if it would stay in the dark box or go out into the light box and retrieve the Fruit Loop.
So the ethanol injections actually, we did see a difference in the rat's behavior. We saw that a higher dosage of ethanol did affect the rat's fear response. It spent more time leaving the dark box and in the light box, and it was more likely to retrieve the food.
Here you can see that the animal does not immediately run back into the dark box when the robot approaches. This means that the slightly higher dose is having some effect on the animal's fear inhibition.
By the third injection, it wasn't afraid of the robot at all, and when the robot would approach the rat, it actually just kind of ignored it and kept eating.
Prior to removing the brain, we had to perfuse the animal with a phosphate buffered solution. This allowed us to see the inside of the animal while the internal organs were still working. Here you can see that the heart is still beating. We also wanted to give a big thank you to all of the TAs who'd spent so much time making sure that we were well prepared throughout the entire project.
From presentation, you're looking at the lateral ventricles. They're going to be spaced out quite a bit from previously where you see they're a lot thinner.
The brain obtained was used to make coronal sections. James, our TA, made it look a lot easier than it actually was. The box is freezing cold, our brain wasn't sticking onto the machinery, or it kept breaking off into smaller pieces. And even with the slices that we did get, we noticed that some of them kept falling off the slides when we were dipping them. That being said, we did the best to obtain slices and carry out the entire histology procedure.
This class was extremely different from all of our other classes in that it really pushed us out of our comfort zone and really challenged us. It made us apply different aspects from different classes and use that knowledge that we learned to merge it into this one project.
We just want to thank Dr. Becker for the opportunity and for all the TA's help, especially Armin. And we're just very grateful for the opportunity, and we learned so much over the semester.
Hot as balls though. It's really gross. It'll be on there.
We're putting it right in the middle.